And yes, that was the answer. You had to get the same number on both sides. And you can do this on any equation. You can't do it on expressions. If you go down like number 6, I think, or 5, they're expressions. Those you can't check, but equations you can. For anything with an equal sign, you can do this and know your grade before you turn 6. So we have -2 times -16, right, minus 7. And does that equal 46? Right. Now with numbers only, do the parentheses. You might be tempted to multiply, distribute, but you don't need to do that here, only when you have a variable. So is -2 times -23 equals 46? Fair enough. Negative times a negative is a positive. You get 46. 46. Same number on both sides. So yes, -16 is. And if we got different numbers, we know we had a mistake or we didn't have the right answer. And you go back and look for your mistake. Because all these are the correct answers. So at this point, if you after I did the first 2, you're like, okay, I know how to do those. Try 3 and 4 on your own. Go ahead and stop when you finish 4, and then just look up and see if it's the same thing. You really want to start building a list in your head of things that you know how to do, or like, okay, yeah, I got that. I tried that on my own, I got it right, I know how to do that. And then things you don't know how to do. That way, when you're studying, you're not trying to review everything from the past month and a half, but just the parts that maybe you don't know as well. Eight minus 8, that equals 4 minus 4. Sure does. -2 is the same. Smaller sheet. Now, even though this is a little bit longer, still can do it. -3 times 12 plus 8 times 12 minus 8. All numbers. Technically, you could just put the left side in the calculator and get the answer, and then put the entire right-hand side in the calculator and get that answer and see if it's the same number. But just for showing you work, let's just write it all out. See what it would look like if you did show everything for your check. I'm not going to require a check on every problem for your test, but you should want to do that by yourself just to see you make sure you get it right. So you could turn in your test, and you could write the grade at the top. If you know what's right and what's wrong. And you wouldn't turn your test in until you got them all right, or you ran out of time. So yeah, all these are the right answers. All correct answers. Let's just say, for argument's sake, that what would a wrong answer look like? Let's say if this came out to -24, and we get an answer of like -8, right? So if you got different numbers on both sides, that's when you know your answer of 12 would be wrong. And you go back and find the mistake and redo it. Okay. Yeah. So that's the first part, just checking your answers. You can do it no matter what equation you're working on. Some are longer than others, but all of it works. Down here, you see how it says expressions for here. There's no equal sign, so here you can't do a check. So this is where we were just really, before we started doing those big equations with a bunch of stuff on both sides, we were just practicing simplifying one side of the equation. So we said any numbers, right, simplify together. So here we have variables and numbers. And we're not adding to both sides. There should be no writing underneath because there's no sides here. Remember, side means side of an equal sign. If there's no equal sign, you can't say, well, I'm going to add 6n to both sides because there are no sides. So that's how you kind of know whether or not you should be doing that. Some people get mixed up and they'll start doing this. They'll say, okay, -9, -9. But this means to do this, you'd have to have an equal sign in between. You can only do it to both sides, the left side and the right side. But if there's no equal sign, then you can't do that. You just add them and simplify them. So over here we have negative 6v, right? There's no other variables. The subtraction sign, same as a negative sign. And then what's 1 minus 3? Negative 2. And generally you put the variable first and the number, but if you switch it, it wouldn't be wrong. But that's just normally how people write. And then here we have positive 9 plus 1. N is 1n, so that's 10. And negative 6 and negative 1? Negative 7. And you can always just punch that in the calculator if you're not sure of positive and negatives. Remember, this is algebra class, not arithmetic. You don't have to miss anything because you didn't know how to add, multiply, subtract, or divide. You can put any of it, fractions, decimals, in the calculator, and it always gives you the right answer as long as you type it in right. So this is algebra, which means you have to know what to combine together. Algebra is you know that these two go together and these two go together. After that, it's arithmetic. Just find out what the number is and you're good. So it's all about the steps and writing them down. Same thing here. We got negative 5 times 1 is negative 5. Negative 5 times negative 4k is positive. So you'll see me, and you've seen me, and you'll continue to see me emphasize negatives. Because after it's all said and done, most people, if they make a mistake, it's on negatives. It's not a number. The number's usually what's correct, the negative is usually what gets in the way. So you've heard me ask the question like a number 8. What number is this? Right? And now you guys got in the habit of saying, looking at the sign. That's a negative 6, not 6. So you do negative 6 times 1, and negative 6 times negative 7. Right? And if you get that part right, then you'll probably get the whole thing right. That was its own question when we took the quiz. I had a problem just about that, making sure we get the negative. So we have 6n, 42n, 48n, and then minus 6. Technically on 7, we could rewrite it as 20k minus 5. Just to put the variable first like all the other answers. But again, it wouldn't be wrong, it's just more familiar with this one. And if you think you know 9, you think you can do 9 on your own, try it. I'm going to go over right now, and then you can see if you're right. Just give yourself a little quiz, and you'll know right away you know how to do it. That way you can kind of check it off in your head, like, yeah, I know these, I'm not worried about them. Or it's like, well, I probably need to practice this several times. You know, rewrite the problem 5 times to make sure I got it down. So you're building a study list in your head of what you really need to worry about and what you can say, I got this. Okay, so. All right, that look good so far? Bottom multiplying? Yes? No?
Sign.
The sign? You guys are starting to catch on. Negative times negative, positive. But if you looked at that and said, oh yeah, that looks good. See all the numbers, 6, 8, 48, and 6, and okay, 16. Yeah, it looks good. Yeah, it's usually not the numbers, it's going to be the sign. So when I say, does that look right? First thing we want to do is, okay, it should be negative, 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 positive, and look at the signs. Negative, 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 positive. Make sure the signs are right. That will save you a lot of issues later on. And then we have variables. So those go together. 48 minus 12. No problem. And negative 16 minus 6. 20. And then later on the last page, we'll just make this an equation, like equals 10 or something, right? And then we'll subtract 22 and divide by. So this is just practicing simplifying one side of an equation without the solving part afterwards. Any clarifications needed on any of those? You guys are well aware to look out for negatives and try to write the variable part first. So let's move on. We'll look at the those special cases where we have maybe no solutions or infinite solutions where every number will work in a check. Let's do those. So we'll review first. If it has one solution, what do all one solution answers look like? They have a variable equal to a number. So if you have a variable equal to a number, you know there's an answer, because that's by definition what an answer is when you have that x equals some number, right, or y equals or whatever. Now, how do you get the no solutions and the infinites? That's when there were no variables and like you're left with like something like 1 equals 0. Something that was not true. You know, they're telling you on this equation, you know what, the number 1 and number 0, they're the same thing. 1 equals 0. And he said, no, in that case, that's what a no solution will look like. And if you have something that just is blatantly not true, and they're saying like 4 is equal to 5. Okay. And infinite is kind of the opposite. If they come up with something that's very obviously true, does 2 equal 2? Yeah, there's no variable, so that's what an infinite solution will look like. So looking at number 10, what is that? One solution, no solution, or infinite? Right, yeah, we have variable equal to number, variable equal to number. So yeah, the answer is 0. That's the one solution, is 0. What about number 12 right below it? No solution, because two numbers. Oh, you know what? Positive 4 and negative 4? Yeah, they're the same thing. Like, no, they're not. There's no solution to that. And number 13? 4 equals 4, well, obviously. Infinite. And you might hear or see in other places this be called all real numbers, just in case that's the same thing. All numbers or infinite numbers, it's just a lot of numbers that are answers. Associate those two together. Infinite solutions. And please write this out and spell it correctly. It's in the directions. So there's no reason to not spell these correctly. Number 11 and the rest of these you have to do a little bit of solving. So we have a variable, 5 times y equals 5.
1.
So x equals 1. So we got an answer of 1. So clearly there's one solution. We got an answer. Got the 14 and the 15. Just got a little bit of sugar property there. We got negative 8 times n, negative 8n. Negative 8 times 4 is negative 32. Now, does negative 8n minus 32 equal negative 32 minus 8n? Yeah. Are those the same thing? Hey, they are. So you might be able to see this from the very beginning. It's kind of a bigger version of this, but we do have the same thing on both sides, right? So it's an infinite solution if you have the same thing on both sides. So we got, but you can simplify a little bit just to show that. Yeah, if you add 8n to both sides and add 32 to both sides, we'll end up with that normal, familiar look of infinite solutions. We'll have 8 minus 8n, 0. 32 minus 32, 0. So the whole side canceled out, so the whole thing is equal to 0. And then the same thing happens on the right side. Everything canceled out. So here's where you can see, yeah, you get the same thing on both sides. But that was the case up here. We did have the same thing. We had negative 8n minus 32 and negative 32 minus 8n. You might be able to spot it sooner, and if you do, that's okay. You can just stop and say infinite solutions. But if you want to check, you might want to keep on going just to make sure. You could do a check on this by picking two random easy numbers and seeing if they both work. If you just make up a number like, you know what, I think n equals 0 is an answer, and you plug in n equals 0, you'll get negative 32 equals negative 32. It's an answer. And then if you plug in n equals 1, right, you'll get negative 40 equals negative 40. So 1's an answer as well. You can show real fast that 0 and 1 are both answers, so it's probably an infinite solution because you have more than one answer. And just, yeah, continue this on. If you kind of got the hang of it, just go ahead and try it on your own and check with me. Give it a shot. 15. Very similar, right? Just the variable on the right was 5a, so subtracted 5a. Both sides cancel. This equals 0, very similar to the left side here. Everything equals 0. But here on the right side, we got 43 minus 40. 3. Which is no solution because 0 does not equal 3. You'll notice with the all reals and no solutions that both variables on both sides are the same number. So you'll have 4 of the same number with a variable. Now that's one way to kind of spot the no solution all reals coming. If you have 4 of the same variable. If they're different numbers, that means they don't equal 0. One side will equal 0, but maybe not the other side. So that being the case here on number 16, variable on the right is positive 3x, so subtract 3x. And you can see here, yeah, these same number, but then right here, these are not the same number. That means they don't cancel out, which means it's not going to be an all reals or no solution. Because for that to happen, all 4 of them will have to cancel. All 4 terms. 2 on the left and 2 on the right. Here, they don't cancel. 4 minus 3, 1. 1x. X equals 0. Minus 3x is 0, so you have 1 solution. So, if you have a variable left over at the end, you have an answer. A variable is your answer. Do not cancel out both sides. And you'll see the same thing on 17. We start off with 28b, tracking that both sides. And subtracting 28 both sides. So here you can see the numbers canceling out both sides. And 2 of the variables canceling out. The right side equals 0. But then here, they don't cancel out, so it's not one of the special cases. Negative 28, negative 6, and negative 34. So, does this have a solution? Yeah, this is just asking negative 34 times what is 0? Right here. Negative 34, yeah, times 0 is 0. The answer is 0 because you can put something in here that makes it true on both sides. And you can prove it just by dividing. 0 divided by negative 4, that's just 0. So once again, one solution. We have a variable at the end, and remember, if you have a variable equal to number, you do have an answer. That's your answer. So just try not to get too keen on trying to have a no solution in all reals when it's really just an answer of 0. Okay. All right, let's take a breather for a second. So on the back is where we kind of really start solving the equations. And I started off with the problem we just finished, so they're familiar. And we said that we want the variable on the top, of course. We want n equals. But we only move numbers diagonally. So right here, we want the variable on top, so we have to move it up there. But because of that, now the variable's up here, we need to move the numbers. So move the numbers away from the variable. So this 10, we want to move it down here. And 3, we want to move up here. 8 just kind of stays there. So we have 8 times 3 on the top. 10 on the bottom, variable by itself. Now this is algebraic. We're just not writing it all out. But when we move things, that was multiplying both sides. Like technically we multiplied both sides by 3, divided by both sides by 10, multiplied both sides by n, and then divided, we did a lot of algebra, but in the end it just looks like they move diagonally. That's all. Okay? But just know it's not just some trick. It is actually, we could write it all out and still get the same answer. So we have 24 equals 10. And if you're not sure about what's it called, algebra or reducing, you could always put in the calculator. Just hit the 24, ABC 10, and then hit Shift ABC, and now reduce to an improper fraction. But if you can just look at this and say, well, divide top and bottom by 2, Still get the same answer, all over 5. So continue on. This is basically the same thing, but I put the negative in here just to remind you, if you have a little negative in front, move that to the top so it's not forgotten. We could even do that here on number 21. Just seeing it at the very beginning, before you do anything, just move that negative to be with a number. That way it won't be forgotten. When it's just in front of the fraction, it's not really next to the 3 or next to the 9, it's easy to forget. So once again, the common mistake is negatives. Okay. So we'll move the x up here. Now the x is on the top, on the right-hand side. The 4 is just going to stay put. And we're going to move that 9 diagonally. So now that's on top. And the negative 14 that was here to begin with, we're going to move that down to here. And if you're going to put this in the calculator, use the parentheses. So you can use parentheses 4 times 9, close the parentheses, fraction button, over negative 14. And then shift fraction and I'll reduce it. So that's 36 over negative 14. And then to reduce, divide top bottom by 2. Then we have 18 over negative 7. Now when you put this in Khan Academy, it told you it wasn't quite simplified. So it usually don't put the negative on the bottom of a fraction. So you can either put it, make it negative 18 over 7, or just make it negative 18/7 like this, put it in front, kind of like how it started. But usually you don't put the negative on the bottom of your answer. Not too bad. Let's look at when we have these more than one term on the top or bottom. Kind of, we just got to finish saying if there's 2 terms, like it was here, you got to use parentheses. So same thing here. We got 2 terms, even though one's a variable. And then move everything from the bottom diagonally to the top. So I'll move that 2 and the 8. So I got 2 times what plus 3 equals 11 times 8. What number? Yep. 2 times what number plus 3 equals 11 times 8. Okay. 2 times what number plus 6 equals 88. Distributed, multiplied, that's 6. And then subtract 8 both sides. So 2 times what number is 82? You can divide both sides by 2. Your answer is 41. And notice how here we do get integer. It's not like a fraction like the other, so it's not that we can't have integer or fraction answers, just sometimes you have a little bit of both. And you can always do a check. If you plugged in 41 right here, 41 plus 3 is 44 over 8. And if you reduced it, it reduced 11 over 2. So even the proportions, you can check. Don't forget, parentheses, 9. And it's negative 3 times 5. Times what is 39. There we go. So 39 divided by 9. Mine doesn't go to 39 evenly, but does it reduce? So you can look at that, and if you know a number that goes into both of those, you can do it that way. If you're not sure, calculator. So yeah, 3 goes into both of those. So you'll get 13 over 3. And leave it as an improper fraction. So never will you put a repeating decimal. Like if you actually divided and got a decimal, this would be 4.3 repeating. Don't do that. And don't leave it as 4 1/3 either. Need the improper fraction. Okay, so that's all the kind of specialty stuff. The rest of this is just basic solving. And we started off with 1 step, then went to 2 step, then variables on both sides, then we put parentheses, and added more to it. So we'll do the next 6, and then we'll be done.
Hey, good class.
Hang in there. Here we go. So on here, the first 2 I want to start with are the ones that have double signs. They have plus and negative and minus and negative. So make sure you handle those correctly. So adding a negative is the same as subtraction. So you want to do this first. Before you add to both sides and any of that stuff, simplify double signs. And over here we have minus and negative is addition. Make it a little smaller so we can fit it. There we go. And then we can do the same thing. Now we have sides because we have an equal sign. We can do something on the right, and then as long as we do it on the left. So we can add 16 here. So we can add 16 here. (16 minus 16 is 0). So we have, our answer is going to be 16 minus 7. Or negative 7 plus 16, which is 9. Yeah. And then it does say to do a check, because you want to know what your grade is before you turn it in. And then if you happen to get it wrong, don't go back and erase it and start all over. Just find the mistake and fix it throughout the problem. If you probably got it 95% correct, and this one's negative. Okay. So it doesn't take that long, and you get a lot in the return. Now, this one doesn't really matter if you remember to change the double sign, because if you look at negative 16, you probably end up adding 16. And it still works. But here it's a little deceitful. Because to solve this problem, you have to subtract 3 on both sides. Right? You're probably not going to look at minus and negative and tell yourself, you know what, to solve this, I got to do more subtraction. It's not intuitive. So that's why we always write out this step to show, 2 negatives make a positive, and then to solve the positive, you have to then subtract. And then quickly, so those were adding and subtracting to solve. One was adding 16, one was subtracting 3. So we also have multiplying and dividing. That's what the next 2 are. So if it's multiplication, I'm doing multiplication, gotta divide. And if it's division, remember fractions are division. So people say, I'm not good at fraction. I'm like, well, do you know how to divide? They're like, yes. So then you can do fractions. Fractions is division. So to undo a fraction, you need to multiply. So if it's multiplication, we divide it. If it's division, multiply. So you don't want to say, well, this one's different because it's a fraction. It's just a division problem. The difference is that we don't write out algebra. We don't write out like this. And we don't use this symbol anymore. We use fractions instead. And then I I know for sure negative divided by negative is positive, so don't forget that part. And then you can do the arithmetic. 7 goes into 9 one time even. 9 minus 7 will be 2, so it'll be 21. 7 goes into 21 3 times, so we'll just use calculator. And then verify to 7 times 13 equals negative 91. You guys should be able to write the grade of your test before you turn it in. You can do a check on every problem that has an equal sign. And you know if it's right or wrong before you turn it in. So none of this like walking out the door and saying, I think I did good, but I'm not sure. You know for sure. Right. So we got 11 divided by 11 is 1. So that cancels out. And 11 times 14 will be 140 plus 14 is 154. And then you can then check it. Does 154 divided by 11, does that equal 14? And sure enough. A few more. A couple more. And then all this checking, that's usually the difference between the A's and not A's. And of course, it's possible to get the right answer without doing a check. But if you're more of a used to getting B's and C's, this is how you get A's. You don't need to do anything faster. You don't need to be better at solving. You just need to check your answer a little closely and catch those little mistakes. All right. So last two for today, we have addition and multiplication. You want to look at this ahead of time and see, what do I have so I know what your steps need to be. If you have addition and multiplication, you're going to have to subtract 7, divide by 3. This you have addition and division, so you know you're going to subtract and multiply. So you kind of know the 2 steps before you start. And then just go ahead and write them out. So we have -7. Both sides, so 3 times what? -36. And then divide by 3. Check it. Seven minus 36 does equal -29. And you'll practice these several times throughout this week so you can get really good, and you might be getting hung up on one part here, one part there, but lastly, same as the last one, don't let this division part throw you off. So this one had a 7 in front. First thing we did is subtract 7. So does this. So that's the first thing we did here. So don't let this fraction here tell yourself, well, this one's different. So what do I do first here? Should I do the 14? So I get the same order. What divided by 14 equals -1? And then multiply both sides by 14. 14 over 14 is 1. -1 times 14 is -14. And then show it here. I did 2 steps here. I did the division, but I also did the double sign. Adding a negative is subtraction. So 6 equals 6. So that's the beginning. Tomorrow we'll start off by doing the last 6, which are a little bit more involved. Okay, so let's move on to the last page. It's going to require a few more steps here. Okay, so let's get started. Remember, anything with fractions, you can just use the calculator. So we have variables on the same side, so we need to combine these. So we got 2b minus 4 over 3. So I can just type in 2 minus 4 over 3. Right? And that's 2/3. So we got 2 over 3b equals 2. And then we can multiply by the reciprocal, 3 over 2 of both sides. Okay, because that cancels out the 2's with the 2 on the bottom, and the 3 will cancel out the 3 on the bottom. So we get b equals 2 times 3 over 2, or negative 2 times 3 over 2. So if you're not sure, just type it in. We got negative 2 times 3 over 2. You get negative 3. Okay. And you can also use a calculator to help you do a check. And you can plug in negative 3 times 4 over 3 times negative 3. And see if it equals to negative 2. Okay. And I'll let you do the work to show that it does work. Use the calculator to check, to solve, anywhere needed. Clear that. Okay. We got variables on both sides. Let's take the variable on the right side and add both sides. And the number on the left side is negative 6. Let's add 6 both sides. So we can do all this in one step, in one line, or we can break it up either way. We have 2 minus m, 2m minus m, which is m, 6 minus 6, which is 0, equals, we have negative 8 plus 6, which is negative 2, and then 2 minus 2, which is 0, so this is solved. And then again, you can go ahead and do a check. Now remember, when you do a check, that this negative here is in addition to this negative here. So we have a negative from the equation, and our answer, m, is also negative. We got to plug it in that way. And once again here, our m is negative. We have positive 2 minus 6, negative 2, negative 8 plus 4, because these two negatives make a positive, right? And then we'll get negative 4 equals negative 4. There we go. Let's go on to 30. 30 has some fractions, but again, this is not easier nor harder. It takes a little longer because we have to punch things in the calculator. Okay. So, and also make sure you know how to use a calculator. So this problem is really not about so much solving. I know you know how to solve it, but can you use the calculator properly? So we got negative 7 over 2 times 3. So I'm going to type in negative 7 over 2 times 3. Right? And make sure you get a improper. So this means negative 10 and 1/2. So we're going to hit shift fraction. So it's really negative 21 over 2. And if you look at this, it's really just 7 times 3 is 21, and the bottom number denominator stays the same. And the negative, don't forget that. So it's not too difficult to do without a calculator. We did 7 times 3. That's as hard as it got. We just had to know where to put everything. Okay, next, it's going to be negative 7 over 2 times negative 4 over 3. Okay. So we can put that in there as well if you're not sure about the fractions. So we got negative 7 over 2 times negative 4 over 3. Again, we want it improper, so hit shift fraction. We'll get 14 over 3. And we got the minus 1. That's already there. And looks like I forgot the variable, so let's put that in there. Alright, so we have some variables and numbers here. These two numbers are on the same side, so the next thing I want to do is actually just simplify that. So 14 over 3 minus 1. I already have it on my calculator, so I can just hit minus 1. Again, improper fraction. So it's 11 over 3. So I'm going to rewrite everything. And write it as 11 over 3. Plus 11 over 3. And just like before, I keep forgetting that. just like before, start with the numbers and then the variables. So 11 over 3 is the number. We're not doing the reciprocal. We're just going to subtract it from both sides. So with adding, subtracting, we always just do the opposite on both sides. Okay. So that's 0. We have 211 over 6 minus 11 over 3. 211 over 6 minus 11 over 3. And then improper, 63 over 2. You see how this problem is not harder because it has a fraction. It just takes a little longer, a little more writing. Nothing we can't write down. And then lastly, we need to cancel out the 2 in the bottom, so I'm going to multiply by 2 on top. And we're going to cancel out this negative 21 on top, so I'm going to divide by negative 21 on the bottom, which is just the reciprocal, and do that to both sides. So that cancels that cancels that. We're left with just n. And then calculator, 63 over 2, which is already on the screen, and just got to multiply it by 2 over negative 21. So I'm going to go times 2 over negative 21. We just get negative 3. Everything reduces really nicely on this one. And it could come out to a fraction, which would be fine. Don't think it's wrong just because it had a fraction answer. Okay. But don't want you to look at this as if you can do it or not. Just look at it as it's going to take a little longer because we have to punch a lot of stuff in a calculator, but definitely that you can do it. And now let's do a few with just parentheses. And these will be a little bit faster, a little bit lighter. No fractions here. So we have negative 3b. Don't forget this is negative 3, so we got a negative times negative is positive 6. Common mistake, most common mistake. If you miss anything, it's probably negatives. And then this looks very similar to the one right above it. We just need to get the variables to the left and numbers to the right. So variable on the right is negative 3. Let's go ahead and add 3. B to both sides. And then we can take the number on the left and add 10 to both sides. We got 10 minus 10, 0. We have negative 5 plus 3, negative 2. Negative 2 times what equals 6 plus 10, which is 16. So positive divided by negative will equal negative 8. Okay. And I'll let you do the checks on that. And last two, just a lot of parentheses. Careful of the negatives. 6 times 1, 6. 6 times 2a, 12a. Negative 7 times 6, negative 42. And negative 7 times 5a is negative 35a. That equals negative 36. So these are all on the same side. So you're not going to subtract 12a or subtract 6 because they're on the same side. You're just going to group 12a minus 35a. So 12 minus 35. Still have a calculator, so if you're not sure, let's go back, delete 35. And negative 23. Negative 23a. We have positive 6 and negative 42. 6 minus 42, negative 36. And that equals negative 36. So let's see here. Let's get the numbers to the right here. We already have the variables on the left, so we didn't have to add or subtract any variables. So we'll just go to the next step and take that number on the left and add it to both sides. Okay. Both of them are 0. So since nothing left on the right-hand side, it's 0. 36 minus 36 is 0. So this is asking negative 23 times what number equals 0. Okay. Finish it up by dividing both sides by negative 23. Negative 23. Right, so we get a equals 0 divided by negative 23 is 0. So we get an answer of 0. We do have a solution, so don't say no solution or infinite. We do have an answer. It is 0. We can plug it in here and here, and we would get the same number on both sides, negative 36. And lastly, variables, parentheses on both sides, which is very similar. 14x plus 49. Getting down to minus 7, we're doing only parentheses this step. So we got 6 again and negative 36. So simplify everything on the same side. On the left, we have one variable, one number. Can't do any simplifying. Here we have two numbers. So we're going to rewrite everything and just simplify that one little part. 49. And then we have 6 minus 7, which is negative 1. And copy down the rest. All that was just to rewrite 6 minus 7 as negative 1. Then we can add the variable on the right because it's negative, so I'm going to add both sides. And then subtract the number on the left, both sides. So we get 14 plus 36, which is 50. 50 times what? That's 0. 50 times what equals negative 1 and negative 49? Negative 50. And 36 minus 36 is 0. So that's pretty straightforward. Divide both sides by positive 50. So negative 50 divided by positive 50 equals negative 1. And I'll let you do the check for that.